So, as mentioned in the email this video is attached to, Andrew is approaching a stoplight moving with a velocity of 30 meters per second. The light turns yellow and Andrew applies the brakes and skids to a stop. If Andrew's acceleration is 8 meters per second squared, then determine the displacement of the car during the skidding process. Well, by doing all these problems, I think I'm starting to figure out the point that you're trying to drive home in class, Dr. Lane, which is that every problem simply has a formula that can be applied to solve it, but that's the issue, is finding the formula and how to go about solving it, and then from there it's just the algebraic expressions for it. So for the solution for this problem, I found that it should start with a construction of the diagram to kind of show what's going on, and that's what I included below, was Andrew's car moving and then coming to a rest as he approaches the stoplight. And then the second step from here I found involves identification and listing of the information that I know, which is, again, that the initial velocity is going to be 30 meters per second. And we can note that the final velocity value can be inferred to be 0 meters per second since Andrew's car comes to a stop. And the acceleration of the car is given as 8 meters per second squared. And what we don't know is the displacement of the vehicle. So from here, we have to figure out which kinematic equation would allow us to determine the unknown quantity. And as it's well known, there are 4 kinematic equations to choose from. But I found the one that's going to work best for this problem is going to be v final squared is equal to v initial squared plus 2 times the acceleration times the displacement. And once this equation is identified and written down, the next step is just going to involve substituting the values that we know into the equation and using the proper algebraic expressions to solve for it, which is exactly what I did. So I start off with replacing vf squared with 0 meters per second squared, and then vi squared with 30 meters per second squared, plus 2 times the acceleration, which was 8 meters per second, and then times our unknown quantity of the displacement. And then I get that formula down to 0 meter squared divided by second squared is equal to 900 meters squared divided by second squared, plus a negative 16 meters per second squared, because he was deaccelerating, that's why that's negative, times the displacement. And then I get 16 meters per second squared times the displacement is equal to 900 meters squared times divided by second squared, minus 0 meters squared divided by second squared. And then to continue to break it down further, I get 16 meters per second squared times the displacement is equal to 900 meters squared divided by second squared. And then I finally get the equation to read the displacement is equal to 900 meters squared divided by second squared divided by 16 meters per second squared. So I get that the car will skid a distance of 56.3 meters before it comes to a stop.